Hello everyone. In this session of CCNA series, I will discuss OSPF DR and BDR. OSPF multi-access network present few problems relating to the flooding of LSAs. A multi-access network is a segment where we have more than two routers, or you can say it's a broadcast network. Here the OSPF router need to exchange routing information with each other. So every router on the network would need to establish a neighbor relationship with every other router, resulting in a significant amount of OSPF control traffic. So it will create an excessive control traffic. For example, 5 adjacencies would be required for each of the 6 routers in the OSPF network to become fully adjacent with all of its neighbors. This could lead to excessive overhead and increased processing. It can also have scalability issues. So in large multi-access network with many routers, the full mesh of neighbor relationship among all routers can become impractical and inefficient. In OSPF, when a link goes up or down, it can trigger a flurry of OSPF routing updates as router exchange information about the changes. So it could create uh, instability. So to prevent such problems, a DR and a BDR is elected on a multi-access network. DR, also known as designated router, is a single router elected by the OSPF router in multi-access segment to act as a central point of communication. It acts as a pseudo node or a virtual router. Its primary function is to minimize the amount of OSPF routing protocol traffic and adjacencies on the network segment. Instead of all routers forming adjacencies with each other, they form adjacencies only with the DR. The DR is responsible for generating and forwarding link state advertisements to other routers on this segment. So instead of, as I said, instead of all routers forwarding adjacencies with each other, they form adjacencies only with the DR. And the DR is responsible for generating and forwarding link state advertisement to other routers on the segment. It collects LSAs from all the local routers and relays them to the appropriate destination. So the DR maintains full adjacency with all the other routers on the segment, ensuring efficient distribution of routing information. The election process of DR is based uh, on OSPF's router priority, and the router with the highest priority is elected as the DR. In case of a tie, the router with the highest router ID is chosen. So the DR can send a packet to all the OSPF routers in the subnet by using multicast address 224.0.0.5. Similarly, any OSPF router needing to send a message to the DR and also the BDR, which we will discuss, can send those messages to all SPF DR's multicast address, that is 224.0.0.6. A significant problem of having only DR is that if the DR fails, a new DR must be elected, and the new adjacencies must be established and has to go through all the exchange process. While this is happening, the network will be unavailable for the transit packets. To prevent such problems, a BDR is elected along with the DR. So the BDR is the router that takes over the DR role if the current DR becomes unavailable or fails. So the BDR is responsible for maintaining a full adjacency with the DR and other routers on the segment. it is always ready to assume the DR role if needed, ensuring network stability in the event of DR's failure. Like the DR, the BDR is also elected based on the priority. The router with the second highest priority becomes the BDR. And if the DR fails, the BDR immediately takes over as the new DR. And a new BDR is elected among the remaining routers. Any routers that are not DR or BDR will be considered as DR others. DR will never reach a full state because they do not exchange LSDBs directly with each other and will always be in the two-way state. That's it for this session. Thank